Alright guys, welcome to RC Mojo. Today we've got something a little different, mainly due to me not being able to get out with the truck. I wasn't going to introduce this little widget for a few weeks, but well, you're going to be getting an early look. Right, if you've watched one of the RC Mojo builds, you'll probably have seen me use my old servo tester. I get emails and the odd comment asking to buy one or where they can find the firmware so they can build their own. But while it works rather well, it really wasn't designed to be easy to put together. If we open it up, we find lots of through-hole components and strip board. With all the shaping, soldering, drilling, we're easily into taking it the best part of a day to put together, and that's no good at all. So that leads us to what I've been working away on for the last couple of weeks. The external layout's quite similar. There's connectors at the top, knob bottom left, a button bottom right, and an LCD in the middle. If we connect up a servo to the output, any RC servo will work, and a RC receiver battery to the input, the box will immediately burst into life. The default is for the knob to directly control the position of the servo. The standard pulse width range is 1 to 2 milliseconds. On the LCD we display microseconds, so it's 1000 to 2000. That spec has been stretched a bit and most radios get well beyond, so the servo tester can go beyond too. Now, if you don't want to sit there twiddling the knob, but you want the servo to keep moving, testing for binding and steering or surface linkages, you can set it up in sweep mode. Hold the button down for a second and it will ask you to set the low point. Hit the button, now set the high point. Hit the button again and the servo will sweep back and forth between the endpoints you set. You can change the speed with the knob. It's also handy if you've got an old servo you want to use but it's a bit glitchy. You can exercise the servo, which usually cleans up the pot. A short press of the button pauses the sweep and another long press drops you back into manual control. For those wondering what's actually going on, I'll connect up the output to the scope. And there's our pulse. You can see the scope is showing exactly what the output signal looks like. And best of all, this scope will tell us how long the pulses actually are. There's the high end, 2080. If I press the button, it will lock to 1500, the center point, and at the bottom end we've got 920. Pretty good, I reckon. Well, yes, you can't actually see it on camera. I think I've probably hit the limit of 1080p, but that's why we have this other bit of test equipment. Its sole job in life is to time things very accurately, which is just what we want to do. We'll need to swap our little test cable round, and there we have the pulse width. So with the tester set to 1500 microseconds, what we're actually getting out is 1499, more or less. To put that into perspective, a lot of basic test gear is maybe good for 0.5% accuracy, maybe even 0.1% on a good day. Well, we're currently at 0.066%. At the low end, 920 microseconds, we're spot on too, and all the way up at the top. Nice. Admittedly, this is at room temperature in a nice environment. If you were to take it outside in freezing weather, it would drift a bit, same as if you were to leave it in a hot car. So that 0.066% is in a perfect world. Even so, it will be way more than good enough for the task. Which brings us on to the next trick. The input connector isn't just for a battery. If we take a bog standard 6-channel Hobby King receiver, or any other receiver of course, connect it up to the servo tester's input, turn on the transmitter and connect a battery, yep, not only does this little box output pulses, it can measure them too. Now you can find out how far out of spec your radio is. It's quite amazing just how far out some are, and it's not just the bargain brands too. Now, to go full circle, the reason for the complete redesign, remember the old box was pretty labour intensive to build, needed a lot of cutting, trimming and all that. Inside this one, it's so much simpler. The front panel of the box is actually the PCB that carries most of the electronics. All the holes are done by machine. The trickiest part of the build is lining up the LCD panel so it sits nice and central. The first unit took about an hour to put together. With all the parts laid out like a factory line, it would probably cut the time right down. Which brings us into the realms of being able to make them to sell. Yes, if you hadn't guessed it, this will be a product on the 74hc.co.uk store. I'm currently waiting for a large box of parts, but who knows when they're going to turn up. This end of the year things seem to go AWOL for weeks. Now, there's one more thing, well, three actually. The processor on the board had some free space in its memory, so I added a couple of silly extras. I won't tell you how to get to them, just that they're there. First, we have the firmware info screen. It's pretty easy to get to, and not very interesting. Second, since I've used an LCD from an old Nokia phone, we have the handshake that goes so well with it, animated by turning the knob. Hours of fun right there. You can impress all your friends like it's 1998. Third, the current temperature. It's not very accurate, the values are a bit noisy, but it's using a bit of hardware that's already in the processor, so why not? If it was halfway accurate, it probably would have made it in as a feature. Well, that's about it then. Thanks for watching. If you liked, do please leave a like, and if you want to see what happens next on the adventures of RC Mojo, you can of course subscribe. It's free after all. Bye guys.